Good morning, everybody, and welcome to another beautiful day. Guess what day it is? It is Science Saturday. It is my favorite day of the month, and I am somewhere new again, outside on the water. So, don't be too jealous. But we are on St. Croix aboard a research sailing educational vessel, and I botched that, but it's okay because we are going to be doing some science experiments today, and I am so excited to learn. And we're joined today. Hey, Mac.
Hi.
Who are you? Where are you? Why are you? Welcome.
All right. I'm Mac. I am a deckhand aboard the Denis Sullivan with World Ocean School. We are a nonprofit focused on getting students out onto the water and giving them an opportunity to come aboard a boat that they wouldn't typically get the chance to come aboard.
That's really cool. And you said student, and we have a student with us today. Come on in here. Alejandro, welcome. Are you so excited to be on Science Saturday?
Very excited.
Yes. I love it. Okay, so what are we doing today?
All right, so we're going to do our water chemistry lesson. This is one of the lessons that we teach our fifth graders that come aboard. We work with fifth graders all over the island, so recently we had a school come out, and this is one of the lessons we did with them just this past week.
Excellent. So, Alejandro, not a fifth grader. We expect you to be an expert. Take it away.
Awesome. All right, the first thing we need to get our water samples together. So I have our freshwater sample.
Okay.
Alejandro, do you want to help me get our saltwater sample? Perfect.
I can tell the excitement.
All right.
Oh, the bucket.
Come on over here because we're tied on. You're going to take this, hold it upside down. Yep. And then throw it down as hard as you can. Nice. All right, come on over and pull her up.
Oh, sorry. Maybe next we get a wireless mic. Look at this activity.
All right.
So, we have our salt water. While you guys are getting this, what are some benefits to knowing about the water quality?
So some of the reasons we look at the water quality is going to be to examine our ocean's health, especially the plants and animals that live in it. And as we go through each of our little tests, we're going to do 4 tests total. I'll talk a little bit about why each one is important for us.
All right, super exciting.
Right. So our first test is going to be temperature.
Turtle.
Alejandro, if you could, stick that in the fresh water right here.
The science is real. I also appreciate that this is a very official looking thermometer with a floaty turtle on top. Pretty sure that's a turtle, not a tortoise.
Yeah, his name's Squirt.
His name is Squirt. I love it.
And go ahead and read me the temperature of that water in Fahrenheit, please.
I believe 93 degrees.
93. That makes sense because I accidentally used the hot water when I poured that.
I was about to say, yikes. Let's hope that's not the saltwater temperature.
Yeah. All right, let's go ahead and try that out.
What do you think the temperature could signify for the ocean temperature, not the freshwater one?
So for our ocean temperature, it's really important for us to know our ocean's temperature just because of especially recent events with climate change and the greenhouse gases. It's really important because all of our fish don't necessarily want to be boiled in the ocean.
That is a very fair point.
What is the temperature on that?
81 degrees.
81 degrees.
All right, so that is alarming. Nice warm day, for us to go swimming, but probably not great for the coral.
Yeah. Unfortunately, though, that is pretty common down here in the Caribbean. Obviously, if we go back up north to New England, where we are in the summer, our temperature is going to change. Up there, even during the heat of the summer, it's going to be probably in the 50s.
That's very cold
Oh, yeah.
for swimming. But think about the sea life that is accustomed to that temperature.
Yeah.
That's perfect for them.
Yeah. It's another great way to look at the migratory health as well for our fish and the water animals.
Migratory health is a new word on Science Saturday. Yes. What is migratory health?
So it's all about following the migration patterns of our creatures in the ocean. Obviously, if where they typically go starts getting too heated and too warm, they don't want to go down there and reproduce. It's not healthy for them. So their migration patterns will change, and that all determines the migratory health of a species.
Okay, that's really interesting. I love new vocab words. Migratory health. We're going to remember it. I'm not.
All right. So our next experiment that we're going to look at, we are going to look at the salinity of our water.
So, Alejandro, what is the salinity? What does that mean?
So salinity is how much salt there is in the water.
Is he right?
He is right.
He's right. Woo! Nice.
All right. Alejandro, can you take this pipette and get some fresh water?
Do I squeeze this part here?
Yep. Perfect. We'll have our fresh water sitting on the side. And then I need some salt water.
And this is a pipette.
Yes.
Science word.
Put a few drops right on this blue spot right here.
Like
Yeah, that's perfect.
Ooh.
All right.
What? How does this work?
So, when you take a look into that, you'll see two sides, one with a larger number, one with a decimal. We're looking at that larger number, and this determines how much salt is in our water. So obviously, this is our sea salt sample. What number did you see, Alejandro?
Do we go where it meets the white line, or?
Yep, so it's going to be dark blue and then like a lighter blue white. It's going to be that line right there.
About 45.
All right, perfect.
All right, so 45. What does that? I do want to look. Yes.
Yeah, so 45,
Ooh.
on average for this area, it is pretty typical. Anywhere between 35 to 45 is what we want to see for our oceans around here.
I got myself a little dizzy there. And so that is the percent of salt in the water.
Yes. Yeah.
All right. What's the rest of it?
The rest of
What's the rest of the percentage? Water? Other things. There's probably a lot in there.
yeah, so it's.
I'm gonna
to
look that up.
It's going to be other particles, as well as just the fresh water as well. All right, now let's take a look at our boat water sample. If you could squeeze a few drops onto that.
How does this thing work?
That is a great question.
Magic. The answer is always magic.
All right, this, thank God, is very accurate.
All right.
What is
Wow.
our reading on that?
0%.
0.
0. Nice. Unless you're cooking pasta, that's good news. I would like to say that that is my first food reference for the morning. I'm going to congratulate myself. No, I did not have breakfast, thank you. So I also see a scientific concept here that we are comparing, so kind of like a base. So we hope we know that the water going through the boat system is fresh water. And so if there were a really weird number, you would be able to compare it and be like, oh, maybe we need to calibrate our equipment. That sounds official, right?
Yeah. So the way a water maker on a boat works, how we got our fresh water. It is basically, it removes all the salt. It goes through 3 or 4 different filters, a UV filter as well, takes out any of the particles in it. So on boats, it's especially important to hydrate, and drink a lot of electrolytes on top of the water that you're drinking. Because as you see, there aren't any minerals at all in our drinking water. It all comes out in the filters.
Interesting.
Yeah. But plenty of minerals in our seawater.
Yeah. And so you said that like 35 to 45% is normal, so that's good. What if it were like crazy high or low? What would concern you about that?
That would definitely be a concern, especially because it could indicate different algae blooms. Some of the algae blooms can be toxic. Some of them are just going to smother the ocean floor, and nothing will be able to survive under there as it should. But yeah, it helps indicate what necessarily is living and the different growths that we are seeing.
All right, that's really interesting. All right, what are we doing next?
Next is
I'm having fun.
our pH.
Oh, okay. So
Alejandro,
we heard that Alejandro did his science fair project on pH this year, and so I am fully prepared to be wowed and just blown away. So, are you ready?
Yeah.
Yeah. Okay. So, while Mac is setting up the test, Alejandro, what is pH?
So pH is the alkalinity or like toxic acidity in a certain liquid. So pH is measured on a scale. From usually it's logarithmic, which means like this.
Excellent vocab word.
The scale, the number you see on a scale is actually like tenfold in actuality. So a more neutral liquid you would see on the scale show up as a yellowish color, while the more toxic it would be a deeper red color, or depending on some scales.
All right.
But the bigger the number, the huge change in color.
Sound good?
Absolutely.
That sounds very
Now
believable
we're
to
gonna
me.
watch some change. Can you put 3 drops of that in here? So one of these has a basic solution in it, and one of them has an acidic solution in it, and both have fresh water. But this is simply to show how our pH reader is going to change based on what we have in there. I'll take that.
Okay, so that was the same bottle, and immediately wildly different colors.
Oh yeah.
Like for a second, I forgot that it was the same bottle. That is crazy.
Perfect. And now we can take our reader and our different pH scales, and we can compare and figure out what exactly our pH reading is. All right, Alejandro, if you could take a look at that for me. And what number are you seeing?
3.5.
3.5. Yeah. I'd definitely say that's it.
That's a very handy little holder there.
Oh, yeah. And our next one. So the lower the number, the more acidic something is going to be. What number do we think this one is? Feel free.
9.5.
So we
And
went
the
from
higher-
3.5 to 9.5.
Yep. The higher our number is going to be, the more basic it is. So water
You're
actually
basic.
falls
Sorry,
into-
I had to.
Our fresh water actually falls into the neutral category, which I would write down if I knew where my pen went.
In the box.
Oh, that's right.
I helped.
All right, perfect. So, pH stands for the potential of hydrogen. Basically, the less hydrogen we have, the less hydrogen we have, the higher our pH is going to be. And the more hydrogen we have in something, the lower our pH is going to be. So our water is H, and O. Our H2O, which is our water, is going to be neutral. This is our handy dandy pH scale. You can obviously tell she's been at sea for a while, a little beaten up.
All right.
But our pure water is going to be 7, which is a nice neutral on our scale.
Okay.
Whereas something like lemon juice is going to be very acidic. So looking at our acidic base that we put in there, it's going to range between apple juice and tomato juice on the acidity scale. Whereas our basic solution was about between hand soap and ammonia solution.
I didn't realize that apple juice and tomato juice were more acidic than black coffee.
Oh yeah. All right, now we are going to look at our freshwater sample and our saltwater sample to see which one is going to be more acidic. If you want to get the freshwater sample. Indicator at the top there. Perfect. All right. Now we're going to pull out our handy dandy indicator again. And again, if you could put, let's put 4 drops in here. Perfect.
That's it? Already.
One more. Yeah.
So what are we hoping for?
So what we're hoping for is for our fresh water to be neutral, because I'm drinking that stuff. I want it to be pretty neutral. And then our salt water, we actually want our salt water to be just a little bit acidic.
Okay. But not super acidic.
Not super acidic.
A few years ago, we learned about ocean acidification and how it affects coral. I don't remember what year, but go back in the videos, watch them all, and find it.
All right, yeah. And taking a look at that, Alejandro, what number do you think our fresh water is closest?
7 and 7.5.
7 and 7.5, which is exactly what we want to see for our fresh water.
Yes. Good job, water maker. Water filter?
Water maker.
Water maker. Water maker has a filter. Now I feel like I'm writing a limerick.
All right, now taking a look at our salt water.
Looks like 9 flat.
9. So our salt water that we just got is a little bit basic. But that could also play a role into not just the water that we collected, but what is in our bucket as well. A lot of the minerals around here that we might have in our bucket, because our bucket itself we use for some of our maintenance projects.
Mm-hmm.
So that could be one of the factors that is changing our water. 9 is not a bad number though.
Okay.
On average, for salt water, we want it to be just a little less than 7.
Okay.
Yeah.
But so that's not too far off.
It's not too
We're
far
also
off.
close to the shore, and so in previous Science Saturdays, we've talked about erosion and things coming off the land into the water, so that could affect it too.
Absolutely. We're also in a port that has a lot of ships coming in and out. That could absolutely affect it, the pollution coming off of those ships as well. But yeah, 9 isn't bad. It's not a bad number for us to see. Nothing for us to worry about.
All
Anyway.
right. Good news.
And our last experiment is going to be density.
Density. Alejandro, what do you think that means?
Density is how tightly packed something's molecules are. So I would assume
Much
to test
smarter
that.
than I am.
So I'd assume to test that we'd be trying to see if something floats.
Oh.
Yes, so he's right. Our density determines how packed together everything is going to be. So these are all the particles in something that is very dense, whereas this is going to be less dense. Typically, things that are more dense are going to sink, and things that are less dense are going to float. So now we're going to see what is more dense, our salt water or our fresh water.
I never considered the word molecule in the density concept, and now I feel like maybe I'm a little dense. Boom. Sorry, guys.
All right, Alejandro, if you could, we'll take it to the floor for this one.
All right. We're going to the floor.
Good.
Oh, geez, my knees.
Just
It's
dump
okay.
a bit of salt water onto this side right here. I'm gonna hold this down because
Good thing we're on a boat.
perfect. All right, and now we are going to take the fresh water and pour it onto this side. Beautiful. Now, go ahead and take the green. Put a few drops of green in that one. Now I gotta take the lid off of it. There we go. 1, 2, 3, 4. Beautiful. And now take the red and do the same on the other side. Nice, nice. And give it a little stir. There we go. Now we're going to see which one floats and which one sinks.
Whoa! What? That's not what I thought was going to happen.
So we put our red on our freshwater side, red on our saltwater side, and our green on our freshwater side. Due to all the molecules and the minerals and the salt in our salt water, that is going to make it a lot more dense than our fresh water that has no minerals in it. So our fresh water is going to float to the top and our salt water is going to sink down to the bottom.
That was so cool. I didn't know the center part was going to come out. I don't know what I thought was going to happen, but that just blew my mind. Mostly that you have this really fun tool to demonstrate that. That's really fun. All right, so what does this mean for my knees? Also, we're good. I'm up. So what is important about the density environmentally? Like, why would you want to know this?
So our density also plays a factor into our salinity as well. If you ever hear about things like the Red Sea, where it is so salty you just float on your back.
I've seen that on Instagram.
Yeah, I've also seen it on Instagram. Can't say I've ever been in person, but yeah, nothing lives in that. People just visit it to float around and take cool Instagram photos, but because of how salty it is, you are actually less dense than the water itself. So you are going to float. People typically have a neutral density, meaning that we don't necessarily float to the top all the time, and we don't naturally sink like a rock. We're somewhere in between, kind of like jellyfish. But
I like that. I am a jellyfish.
But in this case, with very salty water, we are actually positive density rather than our neutral density.
All right, very interesting. I like that. That was really fun. All right, so we looked at temperature, we looked at salinity, we looked at pH, we looked at density. They relate to each other, but also there are other things that we can learn. This was really fun. What else do you want us to know about, like, the water quality of our oceans?
The water quality of our oceans is extremely important, especially nowadays. There's still so much of our oceans that are undiscovered and that we don't know about, and it would be a real shame to lose any species, flora, fauna, that we don't even know about. At this point, due to climate change, things in the ocean are rapidly changing. As a mariner, it means the weather's constantly changing for us, our currents, our wave patterns, things like that. And all of this will help determine basically the health of our oceans. It also determines the safety of mariners on the water as well.
Yeah, that's a really good point. So connecting the health of the ocean ecosystem, it affects so much of our weather and our living conditions, all the animals in the ocean's living conditions. That's really cool. So what do we do about it? What do you want us to do? Like, go home and stop throwing oil in the water. Also, yeah, don't throw oil in the water.
Yeah. Should be common sense, that one. Just be conscious of your water usage, of how what you do is affecting the environment around you. Also, by continuously talking about it. The more we talk about it,
I'm sorry, did you say continuously talk? Sorry.
Yeah, the more we talk about things, the more likely changes to come and people will start hearing us.
Yeah, that's really important. So this has been really, really fun. Can you tell us one more time the name of the vessel, the name of the program, and if somebody on St. Croix wants to see you, what do we do?
Absolutely. So this is the sailing vessel Denis Sullivan. We are run and owned by the nonprofit World Ocean School. Our mission is to get students out who may never get that chance. So we work a lot with the local elementary schools, bringing 5th graders and 6th graders out here, doing day programs. We do some overnight programs, do a little island hopping. In order to fund all of that, we actually do public sales in the evening. So Wednesday through Friday, and then sometimes 2 sales on Sunday. You can go to our World Ocean School website and sign up for one of our sales. All of the proceeds for the tickets and any drinks you buy on the boat will go towards getting more students out here.
I am the height of a 5th grader. I would like to come. All right, Alejandro, you are already an expert. When you came in this morning, was there one thing you learned today, or a new vocab word, or what kind of like blew your mind?
Well, first of all, this experiment was really fun to me. I never done it before, and I find how it works is really interesting. And I also learned more about how all of these different things affect our ocean and why it's important and things like that.
Yes, amazing. Everybody, thank you, Mac, Alejandro, Chantel behind the camera. This has been so much fun. I'm going to go enjoy this beautiful day, grab some lunch, so I stop talking about food. Everybody, thank you so much for joining us on Science Saturday. If you're watching this recording later, thank you for watching. We really appreciate it. I will see you guys next month. I don't know where. Oh, I don't know where. I'm not going to tell you guys. Next month is our 8-year anniversary for Science Saturday. So be expecting possibly a crown. I don't know. We'll see. You guys know I'm a little ridiculous. So have a beautiful day. Enjoy the weather. Enjoy the ocean. And I will see you next month. Bye.